My name is Steve. I'm a Senior Engineering Manager here at CAE Associates. As for our ANSYS Learning Series, I'm going to be talking today about how to manage material property data with the Workbench Engineering Data Manager. Okay. Our objective of this webinar is to provide you with an overview of the Engineering Data Manager, and also to demonstrate the procedure for using the Engineering Data Manager to enter, store, view, organize, and import material property data. Why to learn this? Well, the most obvious reason is because you have to enter material property data for your analysis, but also use the Engineering Data Manager to organize your material data and to share your material property data. You can store data in material libraries, and those libraries can be shared out to other users, or you can use them in other projects. The goal is to speed up your analysis process and to improve your workflow. Engineering Data Manager. I'm sure most of you know what it is. You've probably used it to enter material properties for bench projects. It's defining, storing, and organizing material property data. You can use properties stored in material libraries. And those material libraries can be pre-existing libraries that are ANSYS-defined libraries, or you can take material data that you've entered and store them in your own libraries. And you can use the libraries in other Workbench projects. What I will now quickly is just open up a poll and see from you what you're using the Engineering Data Manager for. So you should see a poll that I brought. And asking is, which features of the Engineering Data Manager do you use now? And you can check as many boxes as you want. And I'll give you a minute to answer, and I'll share the results with everyone. Once we poll out and review those results, I'll move on to the demonstration. Okay. The results with everyone. Expect the majority of responses say they use it to enter new material property data, and that's required for any analysis. That's the way you enter your properties. 36% import material properties from existing libraries. That's good. 8% don't use it at all, so I suspect they're not using Workbench at the moment. Otherwise, they would have to use it to enter property data. Surprisingly, 0% use it to store properties for use in other projects or so that others can use them. So one of the things I want to get across in this seminar is that you can use them for material property storage and for sharing material properties. Okay. I'm going to move on to the demonstration part of it. And I'm going to bring up a model of a fan. And the fan model contains two parts. It contains the fan portion and the case. And I want to assign custom aluminum properties, which are temperature dependent. I want to assign those to the fan portion of the model. And in the case, what I want to do is import some base properties from an existing library and then modify those properties. Okay. Here, my project page. And this is a linked steady thermal static structural analysis. You see at the top of the steady state thermal table, I have engineering data. So this is where I can define my material properties. So to get an engineering data page, I just double click on that item. Brings me engineering data page. There are several components to this page. The one in the middle at the top is the engineering data table, and this displays materials that can be used in this particular project. Then beneath that, for each material that I have highlighted here, it's going to list the detailed property information. Now, this structural steel property is a default property that's available for all projects. And notice down below, the default unit system for that is metric. Now, I can easily switch that unit system. If I go to the toolbar at the top, the units pull-down menu, switch it to US customary, for example. See down in the units column, it switches it. There's a box field or toolbox window left, and this is where you can add additional property items to your materials, and I'll show you how to do that in just a minute. What I'm going to do is I want to add my own custom properties. So first of all, I'm going to add the aluminum properties. So I'll get a name here. I highlight this row in the engineering data table. I'll call it aluminum 1. So I have a question mark here, and that's because I don't have any properties defined for that material. When I want to add properties that are required for my thermal structural analysis, like density, include property. I want the coefficient of thermal expansion so I can account for the thermal strains. Standard value for that is secant coefficient of thermal expansion. Right-click, include property for that one. The isotropic elasticity, that's the basic property required to enter the stiffness values for a portion of the model. So click include property there. And then I'll also add thermal conductivity, which is required for the steady state thermal analysis. Right, include property. Notice in the detailed properties table, I have a bunch of question marks here, and that's because I don't have, you can see in the B column, I have a bunch of yellow fields, and that means that I need to enter data for those properties. So what I'll do here, under data, I'm going to add a value of 0.1 pounds per cubic inch. Expansion, value of 1.28 e to the minus 5 inch degree height. And you need to enter a reference temperature here. That's the temperature at which those thermal expansion coefficients were calculated. That's typically the room temperature. Isotropic elasticity. The way to enter that data is by entering the Young's modulus and the Poisson's ratio. Now for this, I want to enter temperature-dependent properties. All right. Now temperature range that I have here, I should cover the range of applied temperatures in the model. So in the upper right corner of my window, I have, let me click on isotropic elasticity here. I have a table, and this allows me to enter the properties as a function of temperature. So a room temperature value, and then 2 additional temperature points, say 400 degrees, and I want to make sure I cover my full range of temperatures, so I'll go all the way to the max applied temperature of 750. Now your data have different data points in case you'd want to enter those. Young's values at each temperature. Temperature is 10 million psi, for a value of 9 million. 750-degree value of 6 million. Poisson has to be entered for the same temperature points, and typically doesn't change with temperature, so I'm just going to enter the same value for each temperature point. Okay, if I hit the Young's modulus column, you'll notice down at the bottom right corner, it's a nice graph of the modulus variation with temperature. So this window in the lower right corner is always displaying your values, or actually what you entered in the table above. It's displaying down in the graph below. Enter our isotropic thermal conductivity value, and that temperature dependent or could be constant. So if I highlight one, I'll enter some temperature there as well. Those temperature values don't have to correspond to the temperature points in my other table. Temperature, let's say my second point is at 300 and my third point is at 100. And I add the associated conductivity values. 0.001, 0.026, and 0.0029. Okay, and again, plots, in this case, the thermal conductivity versus temperature in the lower right corner. Okay, so aluminum properties are now fully defined. I should give it a description in the D column in the engineering data table if I want. I can anything I want here. And you know, structural steel, it gives the literature information about the literature source, which contains that data. In this case, I'll just type in thin material aluminum, or anything I want there. Okay. Now for the next property, I'm going to import the property from an existing material library. So to do that, I go into the toolbar. Up near the top, there's this library icon. If I click, that toggles between the engineering data table and the engineering data source table. It shows the engineering data source table, and I found a bunch of different material libraries that I can grab material properties from. What I do is I grab a structural steel, a nonlinear structural steel model from the general nonlinear material library. So I click on one. Down this table, it lists each of the materials that are stored in that library. I scroll down a bit. There's one called structural steel NL. NL stands for nonlinear. In that case, it has some plasticity data or yield property data. To include this material model in my project, I have to click on this plus icon. I'll click on that. That's then going to fill in column C with this book icon. That means that it's been added to the engineering data table so that it can be used in the project. All right. Now, if I toggle this engineering data source icon off, I go back to the engineering data table, and you see I have structural steel NL listed in that table. So now available for use within my project. I can change the name of this. Let's say I want to customize this steel. Change the name of it. Let's call it Steel 1. And I'm going to tweak properties a little bit. I want to change here. Actually, I'll change a couple of things. I want to change the yield strength and the tangent modulus. I want to make those temperature dependent. So this is the plasticity data for the custom steel. Highlight that. The upper right corner now has allow to enter temperature dependent properties. I'll put in 70. I'll put in 100 to cover my full temperature range. Yield strength will drop. Put in 3,000 for yield strength at 8 degrees, and let's say a tangent modulus of 200,000. once I've entered that data, it shows the stress strain curves at the two different temperatures. The add here, need to add thermal coefficient and thermal conductivity. So go to upper left in the toolbox, run secant coefficient of thermal expansion, include property. And down near the bottom, I want to include the isotropic thermal conductivity. Click and include property there. So I have a question mark because I haven't entered the new property data. So co-thermal expansion here, I'll use a value of 0.001, degree Fahrenheit, and reference temperature, room temperature. Under tropic thermal conductivity, I'm going to put in, actually, enter the right value here. For thermal expansion, I want to change that to C to -6. Not that high before. And thermal conductivity of 0.001. Okay. So now steel 1, custom steel material fully defined. Now, let's say I want to save these two materials, because I may want to use those in a different project. Share these properties with somebody else. I have to save those to a file, and that's saving them to a library file. So I can hide those properties, go to File, and choose Export Engineering Data. I give the file a name. I can click Fan Materials and click Save. That's going to save it in an XML file format. XML file available to other users, they can read that data in as a new material library for their project. Okay, now what I do, if I have a new project, I'll only have structural steel included in my engineering data table for that project. If I right-click here and delete these two materials, I can always bring back in by going to File, Import Engineering Data. I can locate that library file, fanmaterials.xml, and click Open. And that brings properties back into my engineering data table. Okay. Also, there's a column C here which is listed as source. And that shows the links to the library files. And the structural steel is linked to a general materials library, ANSYS defined library. And then these other two materials are the two materials that we created, and save those to fanmaterials.xml. Okay. Now I select engineering data sources to toggle back to my engineering data sources. I also have the option, let me remove that. If this were a new project, I would have these listed here. So if I want a new library that's been created by somebody else, or let's say I created it earlier in a different project, what I would have to do is select this icon, this button for Add an Existing Data Source from a File. So actually adding a material library to your project. I click my material library file, select Open. Okay, so that adds fan materials to my project. Now, if I look in fan materials, it lists materials, the two materials that I created, steel 1 and aluminum 1. Let's say I want to add another material to that library. I can add the material to it. If I click on this Edit Library, box. I could material here. That steel 2. And then, of course, I can add properties to that material. I could right-click and choose Include Property for density. And let me just a couple of properties here. I'll include isotropic elasticity as well. Put a couple in there. Okay. So now 2 is fully defined. I want to also import material from another library into this library. So just go to the General Materials Library and add it a titanium material. So there's a titanium here. I can highlight it, drag it up to fan materials, and drop it. Now, fan materials, I have steel titanium included there. Okay. Now to save all of this to my fan materials.xml library file, I need to click this save icon here in column C. Okay. Look under source, I have links that are set up. And I can, if I right-click on the link, I can refresh from the link source. And that's set this not equal to link symbol to equal to. So that means it's linked. Okay. Let's see. One more thing I'll show you here is favorites option here in the data source table. I wanted to make one of these materials available for all of my projects. I want to make it easily accessible. What I could do is add that material to my favorites list. So what I'll do is select any material from any library. Make that library is not in edit mode. So I have to uncheck this edit library box. Okay, it brings up this modifications made of the library. Do I want to save? Then I can drag, say, steel 2 up to favorites and drop it. Now on favorites, I've got my standard structural steel that's always in there, and now I have a link to that steel 2 material as well. So to open up a new project, favorites, that steel 2 would be included in there as well. If somebody else wants to include a library that you created in their projects, what you would have to do is click Add an Existing Data Source from File button, and then search for the XML file, the library file that you created, and import it. Once it's imported into one project and that project saved, then any project they open from that point forward will include that material library. Okay. Now I have all of my material properties defined. So to assign materials, I'm sure a lot of you have done this before, I can go to my mechanical window, two parts, my fan part and my case part. Click on, say, the fan part, details pane. Under assignment, I have structural steel. If I select the right arrow, nothing comes up. So it's not displaying my new materials that I created. So what I have to do is I have to select Model, right-click, and refresh materials. Once I do, I can go back to Fan, arrow, and apply aluminum to that part, to the fan part. Same with case. So when I click on the case part, I can right and choose Steel 1. If I have geometry, I can also change the display in the graphics window I can change the display to show those new materials. So under display style, I go to Darrow, Material, and now it doesn't look like the color as much, but it has this color-coded based on material. Okay. One more thing. There is, in the Engineering Data Manager, there's a filter button up at the top. And if the filter button is activated, it's turned on. If I turn that off, you'll notice under Toolbox, I have these additional options here for magnetic materials and electric materials. What this is doing is it's filtering based on physics. So it means when this is turned on, it filters out any property data that is not valid for the type of analysis you're running. In this case, it's structural, so obviously these magnetic and electric properties are not valid. Okay. I'll answer your questions here in a minute. Let me just go back to the slides here. If you material properties that you entered into your CAD program, say Inventor, ProE, or NX, you can import those from the page. So when you import that geometry, those material properties will get imported into the Engineering Data Manager. Include, the Engineering Manager provides a powerful tool for defining, organizing, and storing your properties. A variety of different material models that are available in the toolbox on the left side. So you can add those to your property table. Material data can be stored in libraries. You can use those libraries in other projects, home projects, or other people can access your libraries that you created for those materials. Properties can be temperature dependent, and they'll be plotted in the graph on the lower right side of the window. If you want these materials in your project, you have to make sure you add those materials to your engineering data table. Okay. All right. Again, I'll answer your questions here in just a second. I mentioned that our next webinar here in the series is going to discuss structural element selection. That's going to be next day and Thursday, the 16th and 18th, and that will be presented by Peter Barrett. Okay.